that brings me to invite the next speaker on the stage, which will be Piotr. Yeah, thank you very much, Robin. So probably pronounce your last name wrong. I'm sorry for that. How do I say it correctly? Tynecki. Okay, Piotr Tynecki. Yeah. So I will introduce you. Maybe while you could set up things, or should I help you? Wait.
No, I think I can handle it. I remember the directory name.
Perfect. And
full screen was this one. No.
Do you want to show audio or so?
No, audio is not required.
That should be full screen. This is now showing in the browser, so you could download it, and if you want to open it in a PDF viewer, maybe right click.
Oh, it will take a time. Open with.
That was open with, and then
Adobe Reader.
Yeah, try that. That should be better. And let me just.
But you know, this is a good also.
Okay. Let me just share the screen because I think it stopped because Robin switched.
It will be for me. This one.
If you put it somewhere, great. I will share the entire screen this time.
Let's see if it's gonna work. This way.
Okay, I will quickly introduce you.
Is it okay? You can hear me? Wonderful.
Good work. So it's a pleasure to introduce Piotr. He will present Trapper, an open source ecosystem designed to manage camera trapping projects featuring citizen science and Trapper AI extensions. Camera trapping is now a vital tool in ecological research, generating large, complex multimedia datasets, as we've heard by Robin already. So I think it's a good addition. So Trapper provides a novel solution to these challenges. Unlike other available software solutions, Trapper is fully open source and a web application that utilizes spatially enabled data and supports various media types, including both pictures and videos. It facilitates collaborative work on projects, enables data sharing among users, experts, and citizens, supports data export in the camera trap, the DB standard. The DB stands for?
CamTrap DP.
DP,
standard.
Okay. Data package. Okay, standard, and integrates AI-based object detection and species classification, as well as human-based annotation functionality. Trapper is adopted by various institutions and NGOs across Europe and is gaining traction also in South America. And I'm very much looking forward to your talk. I think audio and so should be working.
Okay. May I have a pilot to change the slide?
That should work. We can try it. This is so connected. Yeah.
Okay. Perfect. Which buttons? Okay. Next.
Let's forward. The lower one is back.
All right.
So the stage is yours.
Thank you. Thank you so much. I'm really happy that I'm here. Thank you for the invitation and for the opportunity to share with you where we are today with camera trapping data management. As a good example of that, I believe I can show you the Trapper possibility. So agenda for my talk is just to give you a briefly understanding what Trapper ecosystem is, what this software, this platform is able to show you, to give you for free. Next, I would like to give you some examples, some real case studies where we implement, deploy the Trapper for different kind of organizations and what kind of effect we achieved. I would like to also share with you our experiments, results of our experiments, which we call Trapper AI. Maybe I will briefly introduce you the offer of the cooperation with our foundation, Open Science Conservation Fund, and at the end of the talk, I will focus on the demonstration of the application. But before that, I would like to introduce myself because I'm a new guy in this community. I'm a software engineer with almost 13 years of experience, mostly in healthcare and bioinformatics in the past, but I also had a chance to work with different kind of e-commerce, fintech, learning projects for different kind of organizations, companies, also for the government. But in the last 5 years, I decided to stay focused on AI research for life science domain. Mostly, I focus on NLP and embeddings, but also in last year, I decided to switch or extend my portfolio with computer vision skills. When I have a time, I'm trying to stimulate local communities in Poland, in Białystok City, where I live. I have a Python users group, which I'm stimulate and organize regular meetings for the last 10 years. And I was, to be honest, organizer of a PyCon conference in Poland. But for now, I'm representing Open Science Conservation Fund. I'm one of the main contributor in the context of technology and innovation. So I will start with the Trapper. I use the word ecosystem, and for some of you, maybe the definition of that word can be different, but for me as an IT guy, ecosystem means that we have a huge project which have different responsibilities, different components. Each of the components have their own responsibility, input and output, and this is how we represent and how we understand ecosystem in Trapper. So what is it? This is the end-to-end platform, to be honest, web platform, which you can use to load your camera trap data, standardize them, make the catalogs of your deployments, your sessions, of course, manage the data, share the data between the users. But behind of that, the engine is able to support you with all repetitive work like detection, classification, and standardizing itself. Trapper is free. It's open source. It's based on GPL version 3 license, which means that you can download it, you can install it in your infrastructure. You do not have to pay anything. Furthermore, you can have, in my opinion, the highest level of safe of your data because you do not have to share those data with the cloud provider or any other platforms which are available from the web or browser level. So you can keep everything in your infrastructure. This is one of the biggest benefits of Trapper. I mentioned it's an ecosystem. What does it mean? That means we have many components, and different components are responsible for different functionalities. Trapper Expert, for example, is dedicated for people who have a background with camera traps data, who knows what the data probably have, and would like to organize the data in a well-structured, access those data for different people on different level, organize the classificators, configure the AI pipeline. So we can say that Trapper Expert, as the name shows, is dedicated for people who have the background and want to organize camera trapping projects. Trapper Citizen Science is the good module for the people who want to focus only on classification, re-identification, animals or humans as well in your resources. I don't want to focus on all of these low-level things related with camera trapping projects. Trapper AI itself is a technology which we developed to handle open source models, but also our own model, and launch them in our ecosystem to detect different patterns, behaviors, or species as well. Trapper gives you the access to API, which means that if you want to work with the data which are organized, which the data were classified in your ecosystem, and make some analysis, make some domain experts reports, for example, in RStudio, in Jupyter Notebook, you can do that. You can use API and ask Trapper to give you the resources, to give you the classification results in camera trap DP standard. I mentioned about Jupyter Hub because it's important to tell that you do not have to exit Trapper to make the statistician analysis, to make the reports, domain level reports, because you can launch the Jupyter ecosystem with Trapper and ask the database for the data, use scientific packages to make all of those analyses if you want it. So it means that you can stay with Trapper ecosystem and do end-to-end work from the beginning to the end. Trapper Client, this is a desktop application which allows you to transfer a massive amount of data to the Trapper, because web browsers are not dedicated to transfer gigabytes of or terabytes of data. How Trapper looks like, I believe I will show you during the demo, but just to give you some first impression, on the left side you can see the screen from Trapper Expert. On the right side you can see classification interface screen from the Citizen Science, which, as I said, the end user needs to stay focused on the image, and classify that image depends on the classification project and classification formula. That person should not stay focused on any other things. So that is why Citizen Science is much more simpler, modern, I believe, and allows you to do your work in a more efficient way. Camera traps projects, of course, required map context. So if you want to switch from the data point of view to the map context, you can easily do that and take a look on your network of camera traps from the map perspective. You are able to load different kind of map layers. You can also export your current map to the GIS software or any other kind of software where you want to make deeper analysis with geocontexts. Just to give you a good understanding why we just split trapper responsibility into the trapper expert and citizen science, I decided to highlight the most important features and differences between those two components. On the left side, we have a trapper expert, as I mentioned at the beginning. If we have a person who has a bio background, but maybe also IT data background, that person can be responsible to organize the anarchy the anarchy which you have in your storage, in your data, and organize everything in Trapper. For example, building the research project, building the many classification projects. Of course, everything works in a context of locations, sites, deployments. So data organization, standardization, this is the first point, which I need to stress very much, that Trapper expert is responsible. AI pipeline customization. In the first talk, we heard that the best choice it will be if we could exclude all the humans detections, for example, and AI pipeline customization allows you to do that you do not want to have humans detected in your storage, or you want to have because you want to track activity and classify different activities. And for example, measure, maybe not measure, but make a research about human-animal conflicts. So AI pipeline customization allows you to do that. You can assign different roles and permissions for different users in your organization. Of course, feedback loop. When citizens or researchers share their classifications and propose what they see on the image, what kind of species it is, what kind of age or sex is represented, we propose you the hierarchy where expert, let's say main expert, can verify your proposals and select which of the classifications is the right, which are not. So this kind of structure was implemented and is working by default, and approve the final classification at the end. Exporting your data into the standardized format, camera trap DP. This is what we implemented. You can export results of your research project or classification project and make some analysis in Jupyter Notebook to produce insights and reports about your camera trapping project. Warnings and messages, this is something what is dedicated, especially if you want to have some kind of warnings, for example, rare species were detected in that locations. This kind of messages you can customize, you can implement by hand, and thanks for that, you can simulate early warning system, for example, using Trapper Expert. So many things related with organization, standardization, and setup. Citizen science is slightly different because in here you have to focus on upload, classification, exploration, let's say. So we can say that citizen science has simplified, modern UI. Of course, everything works on the web. Basic insights on a dashboard level. But what is important to mention, what is not such advanced in Trapper Expert, how it is advanced in citizen science, is annotation. The whole view where you can annotate single object, or you can annotate many objects in the one picture using grouping classifications feature, or you can easily classify the whole sequence or sequences which have the same pattern using a few clicks. So you do not have to spend your time and classify one by one image. If you have a sequence with the same behavior, with the same animal, you can easily classify the whole sequence. If you do not have anything interesting, any objects in your image, you can mark them as empty. You can also save them as your favorite if there is something special in the image and you want to save it and maybe in the future back to it and present to your colleagues. You can manipulate images. I will show you that on the demo. You can zoom in, zoom out. You can do everything what is required to have a good quality of your annotations, including bbox edition, especially when, for example, mega detector or any kind of object detection model propose you the bbox which is not enough good. You would like to introduce your improvements, so you are able to easily to do that. And teams are dedicated for bigger organizations. If you have many active users in your project and you want to, for example, create a team which will be responsible for specific geographic area, you are able to do that, and that specific team will be responsible to classify only images from camera traps located in that polygon, which you will define on team level. Case study. You can ask me, okay, Trapper, sounds interesting. Who is using that software? And if I'm a kind of organization, kind of a team who should focus on that software. So our experience shows that Trapper can be applied by researchers, national parks, hunting associations as well, private companies, NGOs. And here it can be also your story. So if you ask me about the real examples where Trapper was adopted, what kind of projects decided to apply the Trapper, I can say that there is one thing which connected all of them, projects which cannot share the data outside of the unit, outside of the country, because of the GDPR regulations which were mentioned. So you can get the Trapper, you can install it on your infrastructure in the university, in the lab, in the company, and everything stay in that infrastructure, because AI models can be launched on your GPU infrastructure or CPU infrastructure. We do not have to connect with any kind of external services in this case. So I called it intranet, because you can close everything into your unit, into your organization. Or you can install the Trapper in a web server, a virtual private server, or in the cloud, and open the access to all of the people, especially when you have projects for citizens, for people who would like to install their own camera trap in the garden and make some pictures and contribute with their data into your scientific project. So as you can see, we are supporting two kinds of worlds here, and some examples which I can share with you where Trapper was used. It was mostly species conservation, but as I mentioned before, human-wildlife conflicts and early warning systems, and game species management. Trapper AI. We decided to build our own technology to handle the AI support. When I'm saying Trapper AI, I'm trying to say that we have our own architecture, web, backend, frontend, and of course, deep learning architectures to handle the thing that you have to process millions of data in efficient way with good performance. And as I said before, we want to have everything in our infrastructure. So we were not able to use fancy technologies from the cloud, from the big techs. So we decided to implement our own mechanism for that. And we have two components. Trapper AI Manager, this is the advanced queue system, web applications from the client perspective, which handle and managing the tasks executions. A task, it can be detect the object, classify the species, measure the distance between the camera and the detected object. This is the task. And Trapper AI Worker, this is a small component which is responsible only to load the AI model into the memory, execute the protocol which is defined, and return the results to the AI manager. The good thing, which is in this approach, is that it's scalable solution, because you can install AI Worker in many machines, utilize many GPU infrastructures, and all of them can handle the tasks from the manager and speed up massively your data processing process. As I mentioned before, Trapper and Trapper AI itself as well can be installed on Kubernetes, can be installed into the clouds. You can install it into your virtual private server, but also you can deploy everything into your local lab PC or even into your laptop. And the last thing which I need to mention, we decided to build Trapper AI as a technology which is able to easily adopt other AI models. Of course, we have our own models, but we also support Megadetector, Deer AI, and Deep Fauna models as well. So if your admin is able to configure the AI pipelines and you want to compare what kind of results I will get from Megadetector and Trapper AI model versus Deep Fauna protocol, you are able to do that easily in Trapper and compare the results of detections and classifications into the one environment. As I mentioned, we're also developing our own models, and we have, to be honest, we started the research in 2021. But what is important in these slides, our model, which we released in February, was released in Hugging phase, which means you can, again, download it and apply because it's free, it's open source. Right now, we are learning 7, I believe, scenarios. Most of them are based on convolutional neural networks, YOLO package, but also we are training visual transformer, different architecture. And in last days, we decided that we would like to try completely new approach for detection and classification. We are going to use multimodals, Florence 2, because that approach has something what convolutional neural doesn't have. Contexts. When we're classifying the objects, when we are adopting only convolutional neural networks, we see that we can detect local and global patterns. That's okay, but the context is missed. So we decided to use a novel approach. Results are not yet published because everything is calculating right now. Some results from that model, which we shared in February. As you can see, we support 18 classes. The average precision was 97. We measured precision recall, mean average precision F1 score method as well. This model presents good quality in general, but we discovered the results for smaller objects are not satisfied us. That is why we decided to train YOLO V9, so the next version of the YOLO V8. Where the small objects have much more accurate detection results. And probably at the end of the day, we decided to combine both models and make some ensemble approach to use the benefits from both of them. Cooperation. As I said, Trapper is free. So you can turn on your laptop, download it using the Git protocol, install it. There is a documentation, there is a refreshed README, which help you to configure everything. And you can control the anarchy, which probably exists in your data. But what experience shows me that sometimes when you do not have IT department or people with programming skills, administrators, it's good to have a partner who can handle this. So as I said, the foundation, Open Science Conservation Fund, is open for cooperation. We can cooperate with you as an IT partner, so help to configure, install, to share the infrastructure, do everything what is required to start your project easily, even training, make a workshop how to use the interface to achieve your goals. If you are trying to launch a new project and you need a strategic partner, who will be more responsible than just installing the technology and maintenance, you can also talk with us. This kind of scenario was adopted before and tested. But if you need a specialist, only specialist, people who will focus on a specific domain, you can also think about the Open Science Conservation Fund because we are open for bot leasing. Demo. I need to exit the full screen. Maybe not this way. Oh, this is a totally different keyboard setup. Wow. Let me sit down. Oh, way. No. Functional? No. Alt? No. Control Alt? Wow. It was not that mail. Once again. Let me see if, yes, I was able to do that. Wonderful. So what I'm trying to show you, this is the citizen science interface. Because I'm the admin of the application, I was able to see all of the projects, private, public projects. But for this workshop and for this demonstration, I prepared public camera trap 2024 projects, which also you will be able to log in and contribute the data and test the application itself. What I'm trying to do, I would like to show you the perspective of citizen user who, as I said at the beginning, need to focus on upload, exploration, classification, that's all. So what we have to do, we need to propose this deployment session name, which should be unique because it allows you to identify it later. Let's say I have some patterns, let's say depth 001. We need to define date range. So when we launch, when we start the recording, when we're finished. You can optionally decide if you use bait type, for example, food. You need to create a location. To do that fast, you can use the button on the left side, which probably gives you a good, not this time, good, it's a location, probably the closest location which the technology was able to detect. Let's say it's a displace. You need to introduce the location name. Lock name doesn't matter for now. And of course, select data or just drag and drop. Maybe drag and drop will be more expected. So as you can see, I have different data. I just use the data set shared by Deep Fauna on their GitLab because they have empty photos, cars, vehicles, humans, as you can see. So it's a good example to show you the AI pipeline. So if you have a directory of your images, you can easily drag and drop it. And as you can see, I have information that I have 41 of them and just upload. Right now, all of the images are uploaded to our server. If everything will be fine, I should be redirected to the session details view. Right now, I have to wait because all of those images are processed by AI. So I will back to my presentation. And of course, I will back to the web browser in a minute. Because Trapper is an open source ecosystem, our models are also open sourced. It means that we are open for contribution, not only on back and front end level, but also as a domain experts, you can share with us what kind of features are missed, for example, or will be expected in Trapper. So it means we are open for cooperation. Maybe you have your own AI model, which are specified in sex detection, maybe distance between the camera and animal. If you would like to include this kind of model into the AI pipeline in Trapper, it's quite easy to do. We are happy to help you with that. So we have a Trapper Slack, our community is there. That presentation have links. So if it will be shared, when you click on that link, it will be an invitation form where you will be able to easily join to the Slack. This is the link to the this is the address to the demo instance of Trapper, which I'm using right now for the demonstration. If you would like to play with it today, tomorrow, or even the next week, feel free to go here, register your free account, activate it via mail, and you can deploy images. You can work with classification interface, with share Teams mechanism for sharing the data between the colleagues, and look how the application works. And now, I believe, not yet. Oh, okay, so what we have. This is the summary of my deployment. As you remember, I defined the deployment, the location. I could, but I didn't use additional fields. I can, oops, not. I'm able to give much more information in that first step if it's required, if the project specification required that I can do that, but I just missed that because I want to show you how fast you can upload classified data. If you click on that button, you will be redirected to the repository. That repository is only based, it only contains the images from your deployment. So you can easily, for example, see images with animals or with humans, with vehicles. Everything depends on your project spec and project goals. As you can see, humans by default in that projects are anonymized. I believe vehicles as well because of the GDPR regulations. That's correct. You can also turn on blank and see if images which were classified as blank does not have objects. What we know from our experience, and I believe you know that as well, sometimes mega detector have false positives. So we need to fix them by hand. So that is why, for example, this one, this is a good moment to redirect to classification view. Maybe I will use this one. Do I have domestic? It doesn't matter. Oh, this one, it will be a good example. So what I'm doing right now, I can use different fields, different forms, filters to explore my database. Observation type is delivered by object detection. By default, it's a mega detector version 5a, but you can turn on mega detector detection version 6 if you are admin. We are able to classify species, so you can select one of them. For that classification project, I select only 18 of them, but if you need any other species, you can easily configure it on Trapper expert level. So let's imagine I would like to focus on no links in that deployment. Doesn't matter, maybe gray wolf. Yeah, we have a gray wolf. I would like to be redirected to the classification view. And we will stay here for a moment. I believe I have still a few minutes. I like to work with dark mode instead of white mode because when I have a dark mode, that's my private preference, I can better focus on the image, which I'm working with. As I mentioned, you can zoom in, zoom out, you can move the image. For example, you can change the contrast. It's important, especially when you have images which were taken during the night. You can manipulate the brightness as well as saturation. All those filters are not changing your image. This is only for your classification process. If you want to reset the setup, it's easy to do. As I said, you can edit your bounding box. For example, let's imagine mega detector proposed this kind of bounding box by default, so you can easily modify it, and as well as you can introduce your proposal for the observation type species, even for other parameters which were defined on the classification project level. Let's imagine I decided that it was a wolf. When I classified the image, I was automatically redirected to the next image. So thanks for that, I can speed up my classification process. But what I'm trying to show you, I see that this is one long sequence. I'm trying to find if I have other sequence not in this data set. But what I'm trying to show you is that if you have multiple objects into one image, maybe it will be a chance to show you in the data set. Oh, that will be a good example. You have multiple objects. Here, some of the B boxes need to be correct by end user, as you can see. But if you would like to classify each of those objects on species level, you do not have to do that based on each B box one by one. You can use that option, group selection. You can select all of them. As you can see, the color of the frame changed to the red, and you can select the species, which should be, I believe. If not, then don't be mine. I will use that one. So as you can see, that was the group classification level. But if you have a sequence and the whole sequence represent the same object or the same family objects, you are also able to easily classify the behavior, sex, age, species, or any other parameters, custom parameters, which will be defined by your admin. That classification process speed up massively, gives you the possibility to speed up massively your classification process because you do not have to work with each image individually. That's all from my side. I'm open to ask on your questions. Feel free to ask. Thank you for your attention.
So thank you very much, Piotr. We have, I guess, time for one or two questions. Are there questions from the audience? Otherwise, I could start. Maybe I missed it, but you mentioned that you have models in the background that you train yourself.
That's correct.
Do you also provide functionality to train models by the user, or to train your own models? Or is this something planned?
The answer is short, no. Okay. But there is a good explanation why. Especially that if we will do that, it means that we'll have to give you the bigger capacity of the GPU, right? Oh. We are a foundation with limited resources. We are sharing our GPU for your research projects, non-commercial projects, but not for training. You can use our AI, our GPU to predict, to detect, to track as well, because I didn't mention we also have initial support for the movies, for the videos. And tracking system also is implemented, but it's an initial version, so I need to stress that, but not for training from the scratch.
But you could provide your own classification or your own specification for the species, and then you could annotate it manually, and you could use your system for downloading the data then and annotating it and then train it yourself, or so that would work.
That's correct. So yeah. Two paths are supported. You can contribute your data, you can annotate by hand each of them, or part of the work will do the AI and you will fix only a few samples. And we can, if you accept that, we can use your data, your annotation to retrain the next version of our model. Or if we have a formal cooperation and our partners accept that, we can share a data for your unit, of course with animals only, or with blank as well if you want it, and to train your own custom model.
Cool. Oh, there are questions online, but maybe you can go ahead first, and then I'll look at those.
Thanks for the presentation. You mentioned at some point that this platform supports storing geographical information. I was wondering if that's leveraged in any way with the classification that you do. If there's any multimodal machine learning applied there, or any filtering to make sure you're not classifying a species that can't occur in a certain region.
I'm not sure I understand the question.
So for example, certain species of bear might only occur in North America. Would it be possible to end up with a photo taken in Europe saying, no, that's a bear that actually only occurs in North America?
Okay, so if I correctly understand, AI models which we are using by default are based on YOLO architecture, and the list of the species is defined. So if you will put an image with an animal which represents different species, AI model will try to propose you something what he understands. So if you will put American bear and we don't support it, it will be probably wild boar. So this is how it's work when you are using convolutional neural network and your species list is defined. But as I mentioned, when we are using multimodals, not this way, when we will use Florence 2, for example, or Polygamma, or any other CogVM, for example, models, we do not have to train. We can start with pre-trained models, and based on the prompts, which we have our own engineering for the prompts inside in the backend, we can ask that model what you can see on that image. And if you can see the species which Trapper AI default model does not support, propose something else. So in this approach, we can combine convolutional neural networks as default, but if our model is not enough sure about the prediction, we can ask a model which has more general, let's say, understanding what is on the image.
And would this context refer just to the background habitat in the image, or also like metadata, like geographical information?
Yes, we can use metadata, geographic information, and include it into the prompt. Thanks for that, the model can say, okay, so I know I need to work with this part of Europe and be more sensitive, right, because of the species list. Yes, so this kind of approach is possible, but not when you are working with convolutional neural network or vision transformers, because from my knowledge, they don't include the contexts and metadata. Of course, we can combine them with some kind of language models, but Florence 2 is doing it right now.
Okay, thank you.
Maybe a short remark. What you could do is some post-processing. So if you have the taxonomy and you say, hey, the model says it's a brown bear, but the brown bear isn't inhabited in that ecosystem, you can just go upwards one class in the taxonomy level. Maybe this will be some kind of post-processing.
Yeah, the taxonomy is an interesting topic. I think the only thing which I can share with you is that we have the R&D where we would like to have many different models which are specialized, for example, in detection of deers only, or wolves, dogs, and red foxes. Thanks for that, we would like to simulate somehow the taxonomy, because one model, this is what we see in our initial results, one model cannot handle with high accuracy everything. That is why we decided to have smaller models for specific tasks, for specific species, but this is a R&D still, so I cannot share. It will be the future approach.
Sure, thank you.
Thank you.
We have two more questions online, or at least hands raised online, so we'll give them access to the microphone and the cam so they could ask. Okay, so I think one of the people that raised their hand also asked a question already in the chat, so I would read it out. Thank you for your talk. A question, if there is time, how does Trapper handle videos? Can you choose that it analyzes every 10th frame of a video or something like that? And how is that output going to look like?
Citizen science interface is a Trapper expert as well, but Trapper expert, when you upload a video and you want to classify it, your classification is on the video level. So you are not able to specify it right now that in 6 seconds I have specific object with specific classification species level. But in citizen science, we are improving that. You are able to not only play, but also classify different frames into the video. But what I want to stress, this is the initial feature. For example, we are not supporting re-identification. So if the animal will visit many times in the one session, it will be classified as many different objects. So end user have to correct by himself. But right now we are in the middle of the process of implementing re-identification for that, to minimize, not to resolve fully, but to minimize the error of identification, unique identification objects. So yeah, short answer is videos are supported, initial supported.
Okay, then we have to look at the time a little bit. So thank you again for your very interesting talk and for the demonstration of Trapper.
Thank you so much.
So the next program point is a short coffee break. So if the people on site leave the room and then go to the